Let me do it. Okay, so this is the first lecture of physics in my class, and the heading is units and dimensions. Now, with first of all, before going into the topic, let me just tell you something about myself. Just a brief introduction. I hope everyone can see my screen that is there. My name is Astik Udenia. Sometimes students call me AU sir. Okay, and I will be taking your physics. Okay, now I have cleared JEE. That time it was not main or advanced, it was only IIT-JEE in the year 1997. I'm sure not many of you were born at that point in time, with all India rank of 1826. Then I did my marine engineering from Kolkata, and I passed out in the year 2001. And since that year 2001, I started teaching. While I was sailing, I was teaching on a part-time mode. I started full-time teaching from the year 2007. That is when I started full-time teaching physics. Well, in this 21 years of teaching, I have had a few good students, which one of which actually got All India Rank 1 in the year 2015. One of my students, while I was working with an institute, got All India Rank 1 in JEE Main. He also scored AIR 1 in BitSat of that year. He was AIR 2 in KVPY. He was AIR 56 in JEE Advance. His rank fell in JEE Advance because he got chicken pox between main and advance. Actually, he was supposed to get somewhere around 5 or 6. Anyways, in the year 2020, again, one of my online students, he got All India rank 15. He scored 100 percentile in physics as well as in maths. That was in the year 2020, last to last year. 2021, one of my online students, again, she scored 100 percentile in all the 3 subjects. I taught him for a year, then she shifted to a different place. So that has been my journey. Um, Apart from this, there have been lot many students that I have taught. There is no point of telling you all that. Now, how we are going to study physics is quite simple. I don't know why students always fear physics. They always feel that physics is a difficult subject. How many of you think that physics is difficult? Just raise your hands and tell me. How many of you all feel that physics is difficult for 11th standard and 12th standard or for IIT-JEE? How many of you feel it? Raise your hands. 1, 2. No one, no one in the front benches feel that physics is difficult. Back benchers do feel that physics is difficult. Well, I must tell you something that whatever I have taught in the previous years, physics looks a bit difficult to all the kids that come into 11th standard. Now, the reason for that may be because the way you have been studying physics up till now may be different from the way you are supposed to study physics. Now, up till now, you might be studying physics as a subject which only has theory and maybe which has very less numericals. Whatever numericals are there, they are pretty simple. You'll have to learn the formulae, put the formula, get the answer, and you stay happy. Well, it is not as simple as that, because While you are studying physics for JEE or NEET or JEE Advanced, it's somewhat different from that in the sense that, okay, you will have to study theory, you will have to remember formulae, and these formulas are pretty less than what you have to remember in maths or chemistry. In maths and chemistry, you will have to remember a lot of things, lot of things, maybe 4 times more things than in physics. The only small thing that physics has is different from all these maths and chemistry is that you will have to understand the concept. You will have to understand the concept and you will have to apply it. And that is what makes physics somewhat different from these two subjects. If I tell you about the formulae that you are going to study in physics or equations, they are very less compared to what you will study in chemistry or maths. But the application, how are you going to apply those equations, is what makes a difference between physics that you have been studying till now and physics that you are going to study from now onwards. Having said that, let us move and start our journey in physics. I guess you have been introduced to the subject, and I think basic maths is going on. As far as I know, your vectors is done. Yes, yes or no? Please raise your hands. Your vectors is done. Vectors and scalars are done. Class, can you just raise hands and let me know? Vectors are done in the class. Vectors and scalars. No, not done. I think basic maths is started. Differentiation and integration have been done. Yes or no? No, that is also not done. Okay, so I might not have got the correct information. Anyways, let us start to what we are supposed to do, and let me start with the very first heading. I hope you all have got your notebooks. Remember, in physics, how we are going to study. If I call it a triangle, there are three things in that triangle that you must have. The first thing that you have is your notebook. I hope all of you have your notebooks with you. Yes or no? You have your notebooks with you, yes or no? Can I have some raise hand that we have notebooks? You have created, you have made a physics notebook. Only one student has made it. Everyone should make it. Yeah, okay, great, great, great. First of all, you will have your notebooks, and your notes should be very spick and span and clear, because this notebook is going to save you while you will have to revise your topics. So notebook is your first thing. Notebooks or your class note, then your lectures. It forms the next part. Should not miss your lecture at any cost. If you miss the lecture at any cost, you probably have a recording of this, but that recording is not going to help much. You'll have to be attentive in the class and don't miss any lecture anywhere, whether it's any topic for physics, chemistry, or maths. Then you will have your DPPs and your exercises that you will have to solve. I will be sending you that, and you will have to solve this. Then you have your regular tests. And if I combine all these four, that will make your study plan. Now, you might also keep a rough book with you where you can solve questions in rough, and then you can share it. Every question that you solve in the class or as homework, whatever DPP or whatever exercise that question is, you will have to note it down in your notebook very clearly. This DPP, this question, the answer is here. So that when you revise things, it becomes easier for you to revise. Keep your notes spick and span, solve each and every question, mark it in your notebook, mark all the important points in your notebook. If you find a question very good, mark that question, mark it. If you find a question difficult, mark it. If you find a question that helps you in understanding a concept, mark it, because those markings are going to help you when you are going to revise the topic. While you are revising the topic for any exam, you will not get enough time to read the entire notes. You will definitely not get the time to read the test book. Only those marks that you have made in your notebook, the important questions that have been marked, that will help you. I hope you understand this. This is how you should go. This is how ideally a student should go. I never went that way. I never made a notebook. I never noted any question that I had solved. That was a big, 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 big mistake that I did. I don't want you to do that mistake. I hope you understand this. Can I have some reason that you understand this? This is how we'll go about. Raise your hands, everyone. You will be organized from the first day. If you remain organized from the first day, beta, I guess you will do a lot good. And again, everyone asks me, sir, how do I prepare and what is the success mantra to succeed in JEE? And I have a very simple success formula, and I'll share that formula today with you. My success formula tells me that if you want to clear JEE or NEET, when I say JEE, I mean JEE Main and NEET, you'll have to solve 40 questions every day. And this is the shortest trick that I can give you. 40 questions every day. In each subject, you will have to solve 40 questions every day. If you pledge that you can solve 40 questions every day from this day till the last day of your exam, I'm sure that 99.99% no power in this universe can stop you from clearing the JEE or NEET. 40 questions per day, that means 40 questions of physics, 40 questions of chemistry, 40 questions of maths or bio, depending on what you are taking. When I say 40 questions, that 40 questions should be 40 questions with correct answers. 40 questions with correct answer. For that, you might have to solve 60 questions or 70 questions in the beginning. Out of 70, 40 would be correct. Out of 80, 40 would be correct. Slowly, slowly, your ratio will increase. And at one point in time, you will come to a position where when you solve 50 questions, at least 40 of them would be correct. And if you can keep doing that for every day for 2 years, nothing in this universe is going to stop you from clearing the exam. So that's my shortcut mantra, 40 questions per day. If you can do this, well, you are done. Having given you all those important fundas, let us now move on to some things that we must discuss. The name of the chapter is Unit and Dimension, and I hope you understand what do you mean by units and dimension. But before going on to units and dimension, let me introduce. Now remember, in physics, you will get to know a lot of new terms, new definitions probably. Sometimes you will get to know about definitions that you already know. But since you are in 11th standard, the definitions would be of a higher level, a bit higher level. So remember that, and maybe the definition might look a bit different, but remember that is the correct definition. So I'll go around and start with the first thing, and the first heading is physical quantities. I hope you have heard this term, physical quantities. Physical quantities. Anyone has heard this term, physical quantity? Please raise your hand. What do you mean by a physical quantity? Okay, someone has heard it. Now, do you have a mic that can help me out? You can tell me what is a physical quantity.
Hello, good morning, sir.
Good morning, beta. What's your name, beta?
Sir, my name is Vivek, sir.
Hi, Vivek. How are you?
Fine, sir. How are you, sir?
I'm fine. Tell me, beta, what do you mean by a physical quantity?
Sir, physical quantities are the quantities which are measurable, sir.
Great, great. That's a very precise and accurate definition of a physical quantity. Physical quantity, physical, something which is physical. When I say physical, that means it exists physically. And if something exists physically, you can measure it. For example, distance. What's the distance from your house to the coaching center? It's a physical quantity. It exists. You can measure it. Any quantity that exists is physical. If you can measure it, that becomes a physical quantity. So simplest and the very correct definition of physical quantity is what? Physical quantity is a quantity that can be measured. Any quantity that can be measured is known as physical quantity, and I hope you write it. Any quantity that can be measured, any quantity, and I hope everyone is writing, that can be measured is known as physical quantity. Now, if I cite some examples of this, if I cite some example for it, distance, speed, displacement, acceleration, force, all of these are physical quantities. These are the quantities that can be measured. Do we understand this, beta? Everyone of you understand this? Remember, we have to understand small things. Well done. Only small things. And if you can just correlate all those small things, well, physics would be the easiest subject that you will ever come across. Physical quantities are quantities that can be measured. Now that means there would be quantities that cannot be measured. They are definitely not physical quantities then. For example, happiness, sadness, how angry you are, how are you feeling today? Well, you cannot measure it. Therefore, those are not included into physical emotions. Not a physical quantity, you can't measure it. So any quantity that can be measured is known as a physical quantity. I have given you the example. Okay. Now, since they are physical quantities, you are going to study them, and the branch in which you are going to study them is known as physics. Physics, physical quantity, everything relates. Now, these physical quantities can be classified, divided, or subdivided depending on various different ways you can subdivide them. The first division of these physical quantities, if I just write these physical quantities here, which I think you would have studied, the first way in which I can divide these physical quantities is in this way. Any quantity, either it is going to be a scalar or it is going to be a vector. I hope you know what is a scalar and a vector, yes or no? Everyone knows that. Can anyone tell me from the class what's a scalar and a vector? Anyone from any class? Class number 1 is the class which has more students. Class number 2 is the class which is looking new and it has less students. So anyone from class number 1 or 2?
Hello.
Yes,
Hello,
beta.
sir.
Yes, beta. Tell me your name.
Sir, I am Vivek, sir, again.
Oh, Vivek. Vivek is the only student who is there in the class. Not fair. Anyway, Vivek, tell me what do you mean by scalar and vector?
Sir, scalar means the quantities which are having only magnitude, sir.
Scalar quantities are those quantities which only have magnitude. That is correct. What about vectors then?
Sir, vectors are the quantities which have both magnitude and direction, sir.
Yes, vector quantities are those quantities which have both magnitude and direction. So this is one way in which I can classify them. I hope all of you know this, right? We know this. But there is one more way in which I can classify them. I will get to that way. But let us now concentrate on scalar. Now, the scalar quantity has only magnitude. This vector quantity has magnitude as well as direction. Okay. Now, we also know examples of scalar quantities. I hope you know this: distance, speed, etc., mass, time. All these are scalar quantities. For vectors, the examples are velocity, acceleration, force, etc. All of you know this, beta? The examples of scalars and vectors. We are not getting into scalars and vectors. Um, After units and dimension, if required, it's not covered, we will get into scalars and vectors. Now, let us take any quantity, whether it's a scalar or a vector. Now, let us talk about scalar, which only has magnitude. If I talk about the magnitude of distance, how much distance you have traveled. So, if I ask you, you might give, sir, I have traveled a distance of 6 meters. If I talk about vectors, it will have magnitude as well as direction. For example, if I ask what is your velocity beta, so you can say, sir, my velocity is 5 meter per second towards east. This east becomes your direction, and this 5 meter per second becomes your magnitude. Everyone understands this? This 5 meter per second is the magnitude, and this east is the direction. Can I have some reason that we understand this? Everyone in the class? Class 1, class 2? Okay. Okay. Anyways, whatever happens, if you look at this thing, 6 meters, now this 6 meters or this 5 meter per second here, that is the magnitude of that quantity. Now, if I look very closely in that magnitude, I will find two different sorts of thing in that magnitude. One is the numerical or number. Here the number is 6. Here the number is 5. And you have one more thing here. This thing written as m, or this thing written as meter per second. Can you tell me what this small thing m or m per second is known as?
Sir, unit, sir.
That thing is known as a unit. Yes. And that is the first heading of our chapter. Units and dimensions. Unit. When I talked about distance, the answer was 6 meters. 6 was a number. M was meter. Now, if I would have said the same answer, what the distance is, I would have probably said it is 600 centimeters. In that case, your 600 becomes your number, and this centimeter becomes your unit. So whenever we talk about any physical quantity, whether it's a scalar, whether it's a vector, it will always have a magnitude. That magnitude will always have two things probably. One is the number, and the other one is unit. And that is the main heading for this chapter. The first heading for this chapter is unit. Now, at this point in time, since we are introduced to units, can anyone tell me what do you mean by a unit? You know what is a unit? Sir, 5 meter, meter is the unit. Sir, 6 kg, kg is the unit. Sir, 10 seconds, seconds is the unit. How do I define it? Now, sometimes we may understand a thing very easily, very thoroughly, but if someone asks us how to define it, we might get confused. But if you can define it correctly, beta, that means you have really understood this concept, and then you can apply that concept anywhere in any problem. And that is what physics requires. To understand the definition correctly, and then you should be able to apply that definition. If you can do that from the very first day, and that is today, I guess I know that physics would be the easiest topic that you are going to encounter. So let me write the heading now as units. Now I would ask someone to tell me what do you understand by the term unit. Anyone can tell me that? Class 1, class 2. Yes, beta, bull. Class 2? I saw some girl. What is your name, beta? You wanted to say something? Say. First bench. I can see. I have a all-seeing eye. I can see all of you, right from the back benches to the front benches. Tell me, anyone who can tell me what do you mean by a unit? I can't hear you, bacha. Is the mic working? Mic is not working. Hard luck. Mic is not working. Someone in class 1, class 2, mic is not working. Class 1, the bigger class. How do I define unit? Remember, in physics and for me, there is no right answer and there is no wrong answer. Answer only depends on our thinking. I want to know, what do you think? How will you define unit? What do you think is the correct way to define a unit? Anyone? No one? Anyone would like to try? What do you mean by a unit? Okay. No one has an idea probably or are shy to speak. Remember, the more you participate in the class, the more interactive the class is, the better it is. Everyone will understand what is going around in the class. I hope you understand this. So let us try to make the class as interactive as possible. Unit. Now, when I say that the distance is 5 meters, what do I actually mean by it? Okay, before going into that, there is I hope you have heard about a scientist known as Albert Einstein, Sir Albert Einstein. Have you heard about him? Anyone? Anyone? Everyone has heard about Sir Albert Einstein. Class 1, class 2, smaller class. Everyone has heard about Albert Einstein? Yes or no? Okay. Now, he once very famously said that everything in this universe is relative. Nothing in this universe is absolute. Everything is relative. Nothing is absolute. Now, what do you mean by that? Everything is relative. What he means by everything is relative is that whenever we are talking about anything in this universe, any physical quantity, any damn thing, we are always comparing it. We're always comparing something with something. And you will see that in your day to day life as well. For example, if I say today, I'm very happy today, am I comparing it? I am very happy today. Yes, I am comparing it. I am probably comparing it to some day before today, yesterday or day before yesterday, where I was not that happy. So if I say I'm very happy, which is not a physical quantity, so I can't measure it, but still I'm comparing, even though it's not the physical quantity, I'm comparing it. I am very sad, probably comparing it with the other day where I was not sad. Your mom and dad would say that you are not hardworking, you are not sincere. Again, they are comparing you with some students or some kid who they think is very sincere or very disciplined. Whatever we do in our day-to-day life, everything that we do, nothing is absolute. Everything is relative. Everything depends on how you see it. It depends on from where you see it. For example, if I hold this pen, uh, if I just have this, obviously this is a mobile. I mean, don't look at what is there. If I hold it like this, and if I ask you, what do you see? You will see a rectangle. Yes or no? You see a rectangle. Everyone see the rectangle? Please raise your hands. If I hold the mobile like this, everyone sees a rectangle, right? This is what you see, a rectangle. Now, if someone was sitting here and looking from this same mobile from here, what will he see? He will see a rectangle, but he will see a different rectangle. He will see this rectangle. Yes or no? You are looking from the front, you see this rectangle. Someone looking from the side, we call it side view, sees this triangle. Someone looking from the top sees this triangle. For you, it is like this. For someone from the side, it is like this. From someone from the top, it is like this. Same thing, but it looks different. Why it looks different? It is the same thing. Why it is looking different? Anyone? Why is the same thing looking different when I am looking at it from different ways, from different angles? Because it depends on your point of view. Are you getting my point? Everything depends on your point of view from where you are seeing it. It depends on from where you are seeing it. That means nothing is absolute. If I look from this side, it looks like this. From this side, it looks like this. From top, it looks like this. Nothing in this universe is absolute. Everything is relative. You are comparing it. We're always comparing it. We are comparing quantities which are not physical. I'm happy, I'm sad. That means we are also comparing quantities which can be measured. We're always comparing it. Now, the question is, how am I comparing it? When I say distance is 5 meters, have I compared it? No, I've not compared it. Distance is 5 meters. Well, how the hell do you think that I've compared it? Have I compared this? If I've said that distance from my place to the gate over there is 5 meters, the distance is 5 meters. Have I compared it? Do you think I've compared it? How many of you think I've compared it? Raise your hands. Only one student thinks that I've compared it. Everyone thinks that I've given an absolute statement that is true everywhere. Remember, whatever Sir Albert Einstein said was true. Nothing is absolute. Everything is relative. When I say 5 meters, then also I have compared it. With which thing I have compared it? Tell me. Anyone? How I have compared it?
Sir,
When
with
I said
meters.
5 meters, what I actually mean is it is 5 times of 5 times of what? It is 5 times of 1 meter. When I said 5 meters, what I actually meant to say was it is 5 times of 1 meter. And all of you sitting here knows how much 1 meter is. And therefore you can understand how much 5 meter is. It is 5 times of 1 meter. So this 1 meter is the quantity with which I have compared the other distance. And this thing, as you know, is known as a unit. But what this unit has actually done is that it has compared the distance of something with 1 meter. So now from here, I can make a very nice definition for unit, whether it is meter or meter per second or kg or second or any unit. I can make a very precise and very good definition of a unit. Can anyone tell me what that unit ka definition would be? What I can call unit in the very simplest form. What is a unit?
Sir,
What is a unit used for? Yes, it is.
Sir, comparable quantity, yes, sir.
Yes, unit is something that you compare things with, and therefore I can call unit as comparison standards. What is a unit? A unit is nothing but it is a comparison standard. Very precise, very small, very simple definition for a unit. Unit is a comparison standard, which is used to do what? What is a unit is used for? Tell me, what is the use? It is a comparison standard used to compare what? Used to compare.
It is
Used to compare what?
quantities, sir. Physical quantities.
Yes, used to compare only those quantities which can be measured. I cannot measure my emotions, even though I say I am very happy today. I cannot measure it. I am 5 kg happy or 50 seconds happy. I can't measure it. But still, I am comparing it. I'm comparing non-physical quantities. I can definitely compare physical quantities. The things or the instruments that are used to compare physical quantities are known as units. They are used to compare physical quantities. Am I clear with the word unit? Raise hands from everyone will tell me that I'm clear. If anyone has any doubts, please raise it. Class 2, small class, we are ready. So what is a unit? A unit is a comparison standard which is used to compare physical quantities. Do we understand this? Yes or no? Okay. Now, once we have understood what do you mean by units, now I have called this as comparison standards. Instead of using the word comparison, I can also use reference standard. Instead of using the word comparison, I can use the word reference standard. Units are reference standard which are used to compare physical quantities. Okay, so there are different ways in which I can say the same thing. Unit is nothing but a comparison standard. Now, when you're comparing physical quantities, now let us go to the basics. Which physical quantities can be compared? Let us think about it. For example, I have this physical quantity which is 5 meter. 5 meter is the distance of my place where I am sitting to the door right in front of me. Now I'll say the same thing in a different way. The distance from here to there, the door right in front, I can't show you that, is 5 meters. Now I'll say I will take 3 seconds. I will take 3 seconds, which is nothing but time. I will take 3 seconds to go from here to there. Okay. So in first case, I have told you the distance, how much distance is there from here to there. And in the second case, I have told you how much time I will take to move. Now, one thing is distance, 5 meters. The other thing is time, 3 seconds. Can I compare these? 5 meters with 3 seconds. Can I compare it? Which is bigger, 5 meter or 3 seconds? Can I compare it? 5 word number looks great. 5 is 5. 3 is 3. That means 5 meter is more than 3 seconds. Is that so? Can I compare these two? This means yes, this means no. So we will take a vote. Yes or no? Can I compare 5 meters with 3 seconds?
Yes, sir.
How many for no? How many for yes? Is everyone following me better? I don't see raise hand, so I get confused. Can I compare 5 meters with 3 seconds? Yes.
Yes, sir.
Oh, no. The answer is no. I cannot compare 5 meters with 3 seconds. I cannot compare 5 meters with 10 kgs. I cannot compare 10 kgs with 3 meter per second square, because all these are different physical quantities. I cannot compare distance with time. I cannot compare time with mass. I cannot compare mass with acceleration or acceleration with force, because these are different quantities. So only those physical quantities can be compared which are same. I can compare distance with distance, 5 meter with 20 meters. Yes, I can compare. 10 seconds with 15 seconds. Yes, I can compare. 2 kgs with 8 kgs. Yes, I can compare. I can only compare those physical quantities which represent the same phenomena. Do we understand this? So that is the important point that you are going to write for today. What is the important point? Point number one, only those physical quantities can be compared. Only, I hope everyone is writing. Only those physical quantities can be compared that are same. Distance can be compared with distance. Time can be compared with time. Mass can be compared with mass. I cannot compare mass with time or mass with distance or any two physical quantities which are different. All of you understand this? Can I have some raised hands? Simple points. If you keep on understanding them beta and you put them together, then you will become great in physics. I can guarantee you that. So the first thing you have understood that only those physical quantities can be compared that are same. Now let us, since we have understood this, now let us compare two physical quantities that are same. Let me write two distances. One distance is 5 meters and the other distance is 500 centimeters. Now I ask you, both are distances, so I can compare them. Which distance is more and which distance is less? Tell me the answer. Which is
Both
more?
are same. Which are sir? Both are same, sir.
Both are same. Eh? Both are same. How both are same? 5 meter and 500 centimeter both are same.
1 meter
Pakka,
equals to
everyone
what?
understands both are same? Yes or no? Everyone says that both are same. Yes or no?
Yes, sir. Hello, sir.
Yes, both are same. Okay. Now, if I make a small correction here, if I take this out, what I have done? I have taken out the units. And now I ask you, one is 5, other is 500. Are they same?
Sir,
No, they are not same now. But as soon as I put meter and centimeter, all of a sudden magic happens and they become same. As soon as I take them off, the magic disappears and they become different. What is the glitch here? What is the thing that we have to understand from here?
unit, sir.
If I change unit, the same quantity number wise can look different. Are you getting my point, beta? If I change units from meter, if I convert to centimeter, the same thing which was looking 5 now looks 500. Yes or no? So that again takes me to the same concept that everything is relative. If I change the unit, the same thing can look different. If I change my point of view, when I'm looking from the front, it is looking like this. When I look from the side, it looks like this. From the front, it is looking bigger. From the side, it is looking smaller. Front, bigger, side, smaller. But it is the same thing, yes or no? That means 5 meter and 500 centimeter are same thing. Why they are looking different? Because of different units. Do we understand this? Same thing in different units may look different, but that does not mean that it is different. It is still the same. Physical quantities can have different numerical value. You understand the meaning of numerical value? Yes or no? The same physical quantity can have different numerical values if I change the unit, or I can say this, if a unit is changed, the physical quantities may have different numerical value. Numerical value in the first case is 5, numerical value in the second case is 500. Do we understand this concept? Yes or no? Raise hands will let me know that we have understood this. Same physical quantity can look different, but remember it is not different. Units has changed. That is why my reference has changed. It is same thing as saying this. And I'll give you examples. I love examples. For example, these are two boys, boy A and boy B. Now I give a statement, B is taller than A. My statement is correct, yes or no? Boy B is definitely taller than A. It is this much taller than A. B is taller, so the important point is taller. Now I have one more boy coming here or girl, C. Now I say B is shorter than C. My statement is still correct. But now if I highlight only these two things, now my statement looks confusing. In first statement, B is taller. In second statement, B is shorter. How can B be taller as well as shorter? Either he is taller or shorter. He cannot be both. But he is both. And both statements are correct. Yes or no? Why the statements are looking different, beta? Because I have changed something with the statement. Are you getting my point? I've changed the reference standard. In first case, my reference standard was A. A was shorter, therefore B was taller. In second case, my reference standard was C. C was taller, therefore B is shorter. Same thing. I'm describing the same thing. I am describing the height of B, but this height of B sometimes looks shorter, sometimes looks taller. It looks shorter or taller because I've changed the unit. Do we understand this? Can I have some raise hand? The same thing I've tried to explain in different ways. Everything is a unit. Whenever you are comparing anything, you are using a unit. And same thing may look different. So now, come back to the same question. I have written 5 meter and I have written 500 centimeter, and I've asked you which is more or which is less, and you have given me the right answer, sir. Both are same. 5 meter and 500 centimeter both are same. Okay, great. Now alien comes, and we are waiting for their arrival since very long, since the dawn of time. An alien comes. Now, if an alien comes, he has his own units, he has his own system, and he gives me a statement. One length is 500 A, and the other length is 650 D. Now, this A and B are his units, and I have no idea about it. And then he asked me, tell me, gentlemen, Earthling, tell me, Earthling, which is more, 500A or 650D? You are also Earthlings. You are also kids from the same planet, Earth. Tell me, which is more, 500A or 650D? Which is more? The alien is looking for an answer. He is testing our general knowledge, whether we know 500A is more or 650D is more. Which one is more? Anyone? Earthlings? Class 1, class 2? Which one is more, 500A or 600D? 650D? And your answer is?
Sir,
Sir, we don't
650 Sir,
know. Yes?
650 sir.
Why we don't know? In first case, you knew 5 meter and 500 centimeter. You told me, sir, they are same. But now I have put a different question, but I have now changed something here. You don't know what is A and what is D. What is the relation between A and D? Yes or no? So you cannot say which is more. You will say, yeah, my dear alien friend, I don't understand because your units are different. No, I can't tell you which is more. So talk sense. Give me some good information. Give me some correct information. Then I will be able to tell you which is more and which is less. Okay. He said, okay. I understand your problem. I understand. You don't know my units. That is your problem. Okay, now what I'll do is I will put here 500A. So one thing is 500A. The other thing is only 50A. So basically what he did was converted D into A. And he said, now tell me, dear, which one is more, 500A or 50A? Now I will say, now I know the answer. Yeah, now I know which is bigger. Which is bigger now?
500 sir.
500A is bigger. 500A is bigger. Now, I gave you this example to make you understand something which I would not have been able to explain with this example. What is that thing that I wanted you to explain? You can only compare two physical quantities that are same, that represent the same thing. Distance can only be compared with distance. Time can only be compared with time. Mass can only be compared with mass. But one more thing is there, which is important. They must be in the same unit so that you can compare them. Are you getting my point? That alien who came to us for just one question, see how much effort he has taken. That alien who came to us, he used his own units. We had no idea about those units. We could not compare the same quantity. But when he converted it in one unit, we were able to compare them. That means to compare physical quantities, they must be in the same what? Physical
Unit.
quantities must be in the same unit. Do we understand this, bacha? If you want to compare two quantities, they must be representing the same phenomena and they must be in the same unit. Do all of you understand this? Can I have raised hands from everyone in the class that we understand this? Not everyone has understood this? Class 1? Class 2? Okay, I think the time for this class is over. So I will wind up this class. Today's class was a mere introduction. We have introduced the concept of units. Dimension is still far away. We have understood that unit. What is a unit? Anyone can tell me? Unit is a
Comparison standard.
comparison or reference standard which is used to compare or measure physical quantities. Physical quantities which are same can only be compared. I cannot compare time with distance. I can compare distance with distance. At the same time, these two distances must be in the same units. If one is in meter and other is in centimeter, we cannot compare. But you will say, sir, we have compared it. What you have done in your head, which you don't know, is either you have compared, either you have converted meter into centimeters or centimeter into meter. Your brain is very sharp. It has compared, it has converted both the units into one unit, and then you have got the answer. When alien came, your brain did not know what to process, and therefore you cannot compare it. So if you want to compare physical quantities, they must be of the same type and they must be in the same unit. We'll begin our next class from here on. I hope to see you sharp at 8. Please don't be late. I will start the class at 8. So please come before that. Be disciplined. Be very punctual. Please give importance to time. Time is the most important asset that you have. Time once lost will not come back. Make your notes. I will see you tomorrow. I hope you love the class. Take care. Have a nice day, beta. Bye bye.